2.5 Admins, episode 179. I'm Joe.
I'm Jim.
And I'm Alan.
And here we are again. And you've got another plug for us, Alan. OpenZFS Best Practices Part 2, File Serving and SANs.
Yeah, so as we break down the use cases for ZFS and some of the best practices, we talk about two of the most popular use cases, which is serving files, typical Samba, file server, NFS, that kind of thing, and storage area networks, machines designed specifically for storage to other machines in a dedicated network.
Right, well, link in the show notes as usual. Over the holiday, I saw a bit of chatter on Mastodon about Y2K, and then recently there was a piece on the Register, the Nothing Happened Y2K bug, how the IT industry worked overtime to save the world's computers. And I think it is worth reminding people that Y2K was not this big nothing burger. It was actually potentially a very serious thing, and a lot of very hard-working IT professionals prevented a disaster effectively by working really hard.
Yes, there is a lot of meat in that particular burger. When Y2K came down, I was 28 and still a relatively larval system administrator working as an IT manager for a construction company. And in that role, I didn't have to do too much personally as far as, fixing Y2K issues, but I installed one hell of a lot of software updates and patches. And even after installing innumerable updates and patches to operating systems and applications and you name it, I still, despite the fact that I was just a little larval form IT manager in South Carolina, I still ran into a couple of things that I had to personally fix when I discovered that they were doing things like showing dates as, the year 20,100. Because for those of you who didn't live through Y2K, it might not hurt to get a quick primer on the way the dates were actually stored, because it seems a little counterintuitive from a modern development sense. From a modern sense, you might think, oh, okay, so you want to store two numbers. You want to store a month and a day, and you want to do it cheaply because you have a little bitty computer, so you're going to use two integers for that, right? No. Unfortunately, we didn't do it in 2 bytes with 2 integers. Instead, we did it with 4 character values. So you had a character for the tens place and the one place for the month, and a character for the tens place and another one for the ones place, for the days. And the way that they would deal with it when the year rolled past 1999, keep in mind, they're only storing the 9 and the 9. Some systems would decide that it was 1900 all over again. Others would, like I said, you would end up with a date like 20,100 because your 99 would actually roll over to 100, but it would then get tacked on in front of, the existing date. It was nuts.
Yeah. The thing that made it such a big deal is it wasn't necessarily like the operating system was going to stop working. It was all the custom software that companies ran on, like especially back in the 90s. There was less off-the-shelf software, and you didn't have software as a service where you were using some website to do stuff. Companies wrote their own software, hired people and write their own software to manage their specific use case. And if all of those had this problem of we stored the year as 2 digits and it's going to roll over and it's either going to be 1900 or 19,100 or all the different possible options, we're not going to be able to take requests, or things are going to sort the wrong way. The newest orders are going to show up at the bottom, before the very first order from 20 years ago, and all this kind of stuff, that it's just going to make business hard to do or impossible. And it all had to be fixed.
You mentioned sorting issues, and yes, sorting issues were absolutely a common problem. But I also want to remind all you younger folk, in this case, that actually includes Alan. So far, we're basically talking about relatively high-level x86 code that probably isn't going to show worse issues than like sorting problems. But you also have to remember, this was 24 years ago. Programming, defense in depth was a much less developed concept back then. People just didn't give much thought to trapping for errors anywhere that they didn't expect an error. And you already know they didn't expect an error in the date code because they stored it that way in the first place. They've been thinking ahead, then Y2K wouldn't have been an issue. So you're talking about an untrapped error. And the thing about untrapped errors is you don't know what they'll do, and sometimes the consequences can be a lot more severe. Now, if you're working with a relatively high-level language, even untrapped, it's still probably going to devolve to what amounts to an error code. But remember, again, the hardware was also 24 years older. So you had to get a lot more done on vastly less powerful hardware than you do now, which means a lot more software was coded directly on the bare metal. We still had operating systems that weren't even preemptive multitasking, where all code was effectively ring zero given direct access to the hardware. And if there was any multitasking, your app was actually expected to itself say, okay, I'm done with the CPU. You can have it. So this should give you some idea of just how badly things might crash when you have an untrapped error at this low level. You might not just be talking about a funny looking date on the screen. You very genuinely, in many cases, could be talking about entire devices crashing completely.
Yeah, or firmware updates weren't necessarily a thing. Some of those things were not reprogrammable. So if you wanted to update the firmware on the device to fix this problem, you either needed a logic programmer thing or to literally pull out the chip and put in a different one.
I had to buy an EEPROM puller.
Yep. And to think that this problem is solved and behind us is folly as well. The way Unix and Linux count time is counting the number of seconds since January 1st, 1970 UTC. And that works great. Up it turns out, coming up in the year 2038, that number will be too big to store as a 32-bit integer and will overflow and will be back to a negative number. And while 64-bit computers maybe use 64-bit time for that, all your x86 32-bit stuff, which there's a lot of, doing things like controlling oil pipelines, might just freak out.
Oh, and you'd better believe there is a ton of 64-bit code out there that still declared 32-bit integers for that value.
It turns out this same problem has come up a lot sooner. For example, certain software, instead of using seconds for that counter, does hundreds of milliseconds. And so when you just multiply the number a bit, it turns out you can hit that overflow every 24 days. Ask Boeing about that. Go read the FAA's procedures. If you're using certain classes of engines with the Boeing engine management, it has to be rebooted every 21 days because at 24 days, it will crash when the integer they were using to count the number of milliseconds or deciseconds of uptime will overflow and it will crash.
2038 is not that long away.
No,
it's not. And here's the thing that I've been waiting to just, the hand grenade I've been waiting to lob into the room. We're acting like it only becomes a problem in 2038, but it actually becomes a problem the minute you need to store a date in a database of that format that is 2038 or later. And I promise you, there are enterprises out there that are planning things farther out than 2038 right now.
Yeah, and whether it's even like when a contract expires, when a credit card number expires, by sometime in the early 2030s, people are going to have credit cards that expire in 2038.
Banks are certainly already issuing mortgages that are going to go on for a lot longer than 2038.
Yep. But also things like driver's licenses, passports. You get a passport for 10 years. 2028 is only a couple of years away where somebody's going to have a passport that doesn't expire until after the magic date in 2038.
So is this being worked on yet then, in any significant way?
Yes.
On the 64-bit side, this is mostly not a problem, unless the programs are, emulating 32-bit. But the amount of hardware that's still i386 basically is surprising. There's a lot of embedded stuff, especially controlling oil pipelines and factories, embedded stuff. And a lot of this hardware has a life cycle of 20 or 30 years. So we would have needed to fix it in the past to not have it be a problem.
So there's a lot of hardware is going to have to be ripped out and replaced then?
Yeah.
Not necessarily.
Not necessarily, but
it's going to depend. Even if you've got 32-bit hardware, that doesn't mean that you can't have a 64-bit integer. Typically, you can absolutely have a 64-bit integer on a 32-bit platform. The issue is just that it is computationally more expensive to manipulate. Whether that's a problem or not is going to depend on what you're doing with that number, how frequently, and how powerful the hardware you're using is.
Yeah, because the problem comes is it's internally still has to be represented as two 32-bit numbers, and you have to access them atomically, making sure that somebody else is in the middle of incrementing one half or the other while you're trying to read it, and that you read both halves from kind of the same time. And it's much more expensive, yes.
It's more expensive, but it is worth pointing out, although it's more expensive to operate, depending on your language, it's usually not going to be that big a deal for you to implement. You're just saying, hey, I want to declare this as a 64-bit int. And that's all you really need to do. You just may need to be aware that that can have impacts depending on how frequently you're using these values. if you're on really low powered hardware. Now, even if we're talking like a Raspberry Pi or whatever, you're fine. Where this could potentially become an issue is on like embedded stuff with, less powerful like MIPS controllers or, way less powerful ARM or RISC-V stuff.
Well, the other problem though is this is part of the application binary interface. So when an application calls the kernel and says, get time of day, it expects back a certain data structure. And you can't change the size of that without the application knowing. So all the applications have to be recompiled to expect a 64-bit number instead of a 32-bit number. And that breaks all application compatibility. And that's why when FreeBSD was looking at solving this, it was basically, well, we can make a new set of images that are like I386 underscore 64-bit time or something like that, and offer this as a different architecture, basically. Treat it as if it was a different kind of CPU, because all existing applications wouldn't actually be compatible. They'd have to be recompiled to understand that that time's going to be a different size than you expect, because, it expects to be able to jump past the time and get to the value after the time. And if it gets into the middle of the time instead of the next item, it's going to be very confused.
The way I'm hearing that issue is that, keep in mind that you've got to update both sides of it. Because if you're using like a get time of day, then, you need to be requesting the same thing the kernel is going to give you. So if you've updated your application for a 64-bit get time of day, then your kernel has to be expecting you to request a 64-bit get time of day.
Right. You have to update the two together. Otherwise, one side or the other will be wrong.
Right. So we can presume that anybody who's having to work on this 32-bit hardware will probably have an option for that, a kernel built for that when it comes down. We're still mostly looking at, from the application developer side of things, the majority of the work probably boils down to like, I need to actually be making the proper call.
Yeah, or I need to compile the application to expect the right size of result when I do the call.
Right.
Hopefully the answer will be everything will be 64-bit and we can still emulate 32-bit in user space. So 32-bit applications will call the kernel and the kernel will be like, oh, you're 32-bit. Let me truncate that down to 32 bits for you. But then how are they going to represent a value past 2038?
Maybe you spin up a new ABI for that. Maybe you have a get time of day 64 and you just start, saying, hey, developers, you're a scrub if you're still using get time of day. You need to be using get time of day 64.
Possibly. Hopefully we can just get rid of most i386 software by then, but I'm not hopeful of that actually happening.
Okay, this episode is sponsored by Automox. Want to be prepared for any shitstorm that may hit your desk during the workday? Check out the brand new Autonomous IT podcast. Listen in as a variety of experts in the IT operations space discuss the latest Patch Tuesday releases, mitigation tips, and custom automations to help with CVE remediations. Make new work friends. Listen now to the Autonomous IT podcast on Spotify, Apple, or wherever you get your podcasts. That's the Autonomous IT podcast. Recently on Late Night Linux, we covered an article from one of your former colleagues, Jim, Andrew Cunningham at Ars Technica, what I learned from using a Raspberry Pi 5 as my main computer for 2 weeks. And Phelim went off on a rant for about 5 minutes, and we didn't really discuss it much. And then the three of us got talking about it in our private Telegram group, and we decided that we should probably take the discussion on air.
I certainly am happy that, I know that Phelim has already just ranted and screamed about this for 5 minutes straight, because it means that we've gotten that part out of the way and we can just discuss the actual article. Otherwise, I'd need to rant and rave and scream for 5 minutes first. But honestly, the first thing that Andrew should have said he learned from a week of trying to use a Pi 5 as his main computer is that he's not very good at Linux. That's not really an insult. I know Andrew. I've worked with Andrew for years. He's a very sharp guy. He's just not really a day-to-day Linux user. And he has, for a long time, had a little bit of blindness about that a lot of Linux users will recognize from folks who primarily use a single operating system and mistake hard for I don't know this, whereas I know this on the thing that I use every day.
We were specifically talking about the second to last paragraph where he talks about Linux being a teetering stack of independently developed software projects that on a good day just barely manage to work together. And then he goes on about the ARM version of Linux being even less well supported.
And the thing about that is, I don't entirely disagree with Andrew's characterization of Linux as a teetering stack of software, all glommed together that's, just holding together on a good day. What I disagree with is the idea that this separates it from any other modern general purpose operating system in 2024 AD. They are all decades-long stacks of cards with, differing levels of legacy cruft and bugs that were never fixed and long-forgotten use cases that are trying to be supported long past their prime. This is everything. It's all of it. There's not really a huge difference to be found there. And to the degree that you do see a difference in terms of like cruft and is this stuff all just barely holding on by its teeth, honestly, I would cast bigger aspersions at Windows for that than for Linux, because in the open source world, whether you're talking about Linux or FreeBSD, we do have a certain willingness every few years to just chuck a whole bunch of things out and say, okay, that crap is ancient and we don't support it anymore. Whereas Microsoft, given the gigantic cash cow that's based on the Windows operating system, has an enormous incentive to never completely throw anything away.
Yeah, like I've got audio software that ran on Windows 20 years ago that runs fine on Windows 11. Try doing that on Linux.
Right. And possibly even worse than that. We've already mentioned that Microsoft doesn't ever really want to throw things away because it will make somebody who's giving them money unhappy if they do. The other thing about that is because they never throw anything away, they have a really ugly tendency to never finish anything either. You look at the control panel, it's getting harder and harder to find because Microsoft wants you to just use the settings app for everything. The problem is half of the things in the settings app don't work. Half of the rest don't work as well as what was in the control panel, and they keep monkeying with the settings app, and they keep nerfing some of the old apps in the control panel to redirect them to settings, but there's no one place you can go to manage all the things that you used to manage in the control panel. There are some things that you can do in the settings app, although you might have a much better job of it in the control panel app because, again, that app kind of sucks. It's really half-baked. There are other things that now you can't do in the control panel either because Microsoft has, as I've mentioned, they've been trying to nerf the control panel and, turn what's in there into redirects to settings. So in some cases, functionality that you absolutely need that is not available in the settings app, you can now not find in the control panel either, which means you better hope you're running a pro version of Windows so that you can fire up MMC and then load in the applet that you need directly into MMC. It's a nightmare. Now, Andrew doesn't notice this stuff because Andrew has a well-worn path in his chosen operating systems. I believe he's a Mac person as well as a Windows person, and he does what he needs to do, and he knows how to do it. But then you put him in front of a Linux box, and because he is a technical person and a sharp guy, he can make it work. He's just still hasn't quite figured out the difference between this is hard because I don't know how to do it, and this is hard because it isn't done well.
Yeah, and like looking at some of the stuff where he was talking about overclocking the Raspberry Pi and that making it slightly better, it's like, well, at some point you have to realize that it's a Raspberry Pi. It is not a high-end laptop. You can't compare it to your Apple Silicon Mac that you have and expect to get the same performance out of this designed to be as cheap and cheerful as possible Raspberry Pi. And, that's not necessarily that ARM is slower because, the Apple Silicon Mac proves that. ARM can be really fast.
But this particular ARM is not fast.
Exactly.
And the other points, Andrew made a big deal about the ARM ecosystem being shakier than the x86 ecosystem under Linux. And again, he's not wrong there. That's a true fact. The thing that's wrong is laying the blame for that at the operating system's feet, when a lot of the issues, although I suspect he doesn't fully realize this because he's not dialed into these details the way that, Alan or I are, and in some cases, even the way that Joe is. I don't think he quite realizes that it's not Linux's fault that you can't just grab an installation of whatever random distribution of whatever operating system and install it on any random ARM device the way that you can do exactly that on any random x86 device. That's not a Linux failing. That's a very distinct change in platform design. Once you go over to the ARM side of the house, they stopped being interested in this glorious wide open bazaar that those of us in the x86 world have been used to now for going on 4 decades. Instead, the ARM platforms have been implemented as very tightly integrated vertical stacks. So an operating system that will install on one Android phone won't necessarily install on another one, and certainly won't necessarily install on a Raspberry Pi 5 or a Pinebook Pro. You have to have custom stacks for each of these devices. But again, that's a hardware decision, not a software decision.
Yeah, the fact that each hardware is can be completely different. Now, on the ARM server side, they've tried to solve some of this. ARM has a certification process called Server Ready. That means that this certain baseline of stuff is going to be the same no matter what ARM server you buy, if it's Server Ready certified. And I think we might start to see more of that even on the laptop side, although maybe not. When Microsoft builds their own ARM hardware to sell you Windows on, they're not necessarily going to be interested in you being able to do other things with it. And kind of talking about other stuff we talked about in the last couple of weeks, the just general death of general purpose computing, where you're going to buy a device that's for this one thing and that's all it works for and all it's supported on, and you wanting to run a different OS on it is your problem, not something the industry cares about. But on the server side, when we get to booting with EFI instead of requiring a different custom U-boot for every different thing of ARM, just the fact that ARM v8 is 64-bit and a bit more common. Looking at the way FreeBSD dealt with this, back when ARM v7 was popular, there was a separate image you needed for the Banana Pi versus the Raspberry Pi 1 and 2, which were both separate, and the Orange Pi and all these other devices all had to have a special custom image just for that one device. Whereas, at least with ARM v8, there are some generic images that'll work on most of the devices. But even there, it really depends on the device. Some devices use ACPI, the same BIOS configuration set that x86 hardware uses for when the computer starts, for it to probe and see what hardware do I have. Whereas, especially more of the embedded side of stuff on ARM, like the Raspberry Pi, has what's called a device tree, which is literally a binary configuration file that says you have these devices at these addresses and they're never going to move or change because, they don't have a PCIe slot where you're going to jam in a card that they weren't expecting. And understanding those differences is where a lot of, I think, this frustration comes from, where, the ARM is not x86, but neither is PowerPC. Do people remember there are other architectures beyond x86?
Well, on the consumer side, no, they probably don't, because, if you're a Mac person who used PowerPC, you probably just thought of that as a Mac. Mm-hmm. And, when the transition from PowerPC to Intel came, you probably just thought of that as the new Macs. And most of the normal people I talk to who have Mac M1s, they're not real clear on the distinction between, M1 and x86 either, other than, again, to them, it's the new Apple stuff that's so much better than the Apple stuff they had before that. Mm-hmm. And some of their programs need to be a little bit different to run their best on the new Apple thing that's better than the old Apple thing. But yeah, you're just not really delving into platform architecture as a normal person.
Yeah, and while the applications have to be compiled for ARM, in general, especially even on Linux side, most of the applications aren't going to actually need to be changed to work on ARM. They just need the packages to be built specifically for ARM and the kind of configuration of ARM that the device happens to be. And the kind of very different versions of ARM that are out there do make that a little bit more complicated. But again, ARM v8 versus v7 is really avoiding some of that discontinuity and fragmentation.
Because Andrew says, along with the Asahi Linux project for Apple Silicon Macs, the Pi is probably the best and most visible hardware for pushing consumer Linux forward into a more usable state.
Yeah, and I think a lot of this is also just shared with general Linux. And I think the ARM server hardware, especially as being used by almost every cloud provider, like the Ampere stuff is used at Google, Microsoft, Oracle, Tencent, and a bunch of others. And then Amazon has their own. I think Google's building their own now as well. But all these different providers deploying huge numbers of ARM servers because they'll use less power and be able to get similar performance. I've got to play with a 160 core 3 gigahertz ARM machine. It can beat the pants off something, an Intel server or an AMD server easily.
And you believe in trickle-down effect in this case?
As far as support for the hardware and drivers and the application ecosystem, to some degree, yes. That basically any support for ARM is better for all support for ARM. Especially the differences that are specific to ARM are going to be in the operating system, the Linux kernel part, and less specific to, the applications you're trying to run, right? X11 or Wayland and all that stuff doesn't need to be rewritten to work on ARM. It just needs to be compiled for ARM.
Essentially, we're talking about some heavy monkeying around with makefiles. It is work that needs to be done, but it's not like rewriting all of the software. And I think the biggest example of the kind of trickle-down effect that Alan's talking about here that you are likely to get as a Linux user from, these big Ampere and Graviton servers is as more and more people are using those things in prod, more and more of the applications that you expect to use from repositories have somebody going over them and doing that work of reconfiguring the makefiles to have the branch to build properly for the ARM stuff that is at least more likely to translate down into whatever consumer ARM device you may have. Now, where I'm not as optimistic as Alan is, I don't think Server Ready is making it across that barrier onto consumer devices for ARM. I think that the people who make ARM devices like their tightly integrated vertical stacks. The majority of them were already going out of their way to try to differentiate themselves and break interoperability between their devices and other people's devices. You look at, nobody wants to run stock Android on whatever phone they built. They want to monkey with it and make it look completely different. And it doesn't have to be better. It just has to be different enough to say, oh, I know for a fact I'm using a Samsung phone right now, not that filthy bare Google stuff or, the whatever it is that you don't like. Now, is that consumer friendly? I happen to think it sucks, but I'm also 52 years old and I know what corporations do. And I think they're living their happy little lives right now and they're not going to be interested in changing that. Now, where I am hopeful is I think that the entire ARM ecosystem, it's got a window and it's closing. I think that RISC-V is going to come for ARM. And I think that because of the much more open nature of RISC-V hardware, the odds that we're going to see consumer devices that are more consumer friendly are a lot higher on that side.
Yes, although the one thing I'll say for RISC-V is I think they have the fragmentation problem going even worse. Because it's so open, you can build a chip with or without each of these hundreds of extensions. So you can actually have machines that don't know how to divide. You can build a RISC-V processor that just can't do division or, have different extensions or work with different size integers and so on. And because you can pick and choose all these things, you end up with a lot more possible combinations, and trying to support those in the Linux kernel and the FreeBSD kernel is already a bit of a pain. And I think it will make trying to do general purpose computing on them maybe more difficult. Just that you can't just take any RISC-V device and try to just build FreeBSD on it and have it work.
I think there will be a separation between general purpose RISC-V devices and embedded RISC-V devices that aren't expected to run a full Linux or BSD stack. They're only expected to do the things they need to do with the hardware that they have in them. But I don't think that's going to be that confusing. I'm more concerned that nobody will bother building general purpose computing devices at all than I am concerned that if we have the will to build them, nobody will be able to figure out what is or isn't a general purpose computing device, or be able to keep the ones that are designed as general purpose devices largely interoperable.
Yes, I think the general purpose devices are going to become harder and harder to come by, and that getting something that will work with everything is going to be less of a thing anybody cares about doing. On the ARM side, it'll be interesting to see what some of the providers, like Microsoft, released this ARM dev kit hardware, which I bought one of, and with the help of some people from Cloud, we got FreeBSD to boot on it and work. And it's relatively generic hardware, but it turns out it's just the same guts as a Lenovo ARM laptop. It's exactly the same model. But when Microsoft releases their actual hardware, it's probably not going to be something so generic, right? This was just something off the shelf they could buy and sell as a dev kit, so people would start making their applications work for Windows on ARM. And on Linux, that hadn't happened as much before. People weren't, there's no company behind the desktop applications you're using on Linux that's buying developers dev kits to make sure the application works on ARM before the hardware. But it's not stopping us from catching up.
Let's do some free consulting then. But first, just a quick thank you to everyone who supports us with PayPal and Patreon. We really do appreciate that. If you want to join those people, you can go to 2.5admins.com/support. And remember that for various amounts on Patreon, you can get an advert-free RSS feed of either just this show or all the shows in the Late Night Linux family. And if you want to send in your questions for Jim and Alan or your feedback, you can email show@2.5admins.com. Tom says, Synology is deprecating one of its OSs for the older NASs. For those who have a fair amount invested in them, Are there any FOSS alternatives other than pulling the data off and tossing the kit?
That'll mostly depend on what the file system is, but since the Synologies are typically relatively normal Linux, then you would be able to import the file systems on some other FOSS-based Linux NAS, but it's not going to keep all of the other bits from the Synology, all the applications and so on. I don't think there's a kind of a drop-in replacement for the Synology OS itself, the one that's being deprecated. But as far as not having to copy all the data off and just being able to mount it, that should be relatively straightforward.
My understanding was that Synologies have like a weird ButterFS with some abstraction layer, though. So doesn't that make it more difficult to mount on a normal Linux system?
A little bit. If you're a relatively veteran sysadmin, it's not that daunting. If you don't hit the level of relatively veteran sysadmin, it might be a little daunting, but you can get through it. You need to be familiar with LVM and Butter. You're not really going to be able to recreate their stack exactly. I wouldn't recommend trying to get the whole thing up and running in its entirety. But if you just want to be able to like mount it read-only and get the data off, you really just have to be able to import the volume groups and then reassemble the Butter volume. It's not that bad. Another thing that's probably worth mentioning is there is a project called Xpenology, Xpenology, which allows you to boot Synology firmware on a generic x86 device. So Xpenology itself it's a custom bootloader that you need to get the DSM firmware running on your x86 box. And that's not all that hard to get going. Now, I do have to mention, although this has not really been tested in court, the legal status of doing that is pretty murky. So if you're just some person at home who wants to carry on basically the way you have been without buying a super expensive new Synology box, that might be an interesting solution because you would be able to just buy or repurpose, a generic x86 machine, throw your existing drives from your Synology in it and boot it into Synology firmware, but a newer version. Maybe that's a cleaner upgrade path, but I wouldn't recommend trying to do that at work.
Right, well, we'd better get out of here then. Remember, show@2.5admins.com if you want to send any questions or your feedback. You can find me at joerest.com/mastodon.
I'm at jrs-s.net/social.
And I'm at Alan Jude.
We'll see you next week.